Okay, so a cheat sheet for certain counting problems, and we're going to break the counting problems. So sequences, we're building up different sequences. We're going to break them up into with repetition and without repetition. So with repetition and without repetition. Okay, and then we're going to be interested in sequences. Okay, so sequence, so a K sequence and a K subset. So with repetition, without repetition, we've been discussing repetition so far. A sequence means that the order matters, and a subset means that you don't care about the order. So in all cases, think about it as we have n objects. Okay, and we're interested in constructing a sequence of length k. Okay, and if it's with repetition, okay, then each element of my sequence can be one of the n objects. So the number of ways to do it is n raised to the power k. Okay. If it's without repetition, think of this as you have n runners in the race, and I have to select k for the top k finishers. So without repetition, it's going to be n times n minus 1 times n minus 2 all the way down until I have all my k objects. So this is going to be n factorial over n minus k factorial. Okay. So constructing these sequences. So a k sequence with repetition from n objects, without repetition from n objects. Okay. Now, if it's a subset, the order doesn't matter. Okay. So if we do with repetition, so if we're picking a subset and we're allowed to repeat the objects, then it's exactly the goodie bags. Okay. So it's exactly the goodie bags where my goodie bag has k. Okay. And I have n types of colors, n types of candy, let's say, and I'm allowed to repeat colors. Okay. And we saw before that, it's k plus n minus 1, choose n minus 1. Okay. We developed this formula last time using correspondence-based counting. Now, if it's without repetition and it's a k subset, so the number of ways to choose k objects from n objects without repetition, in other words, without replacement. Okay. So then this would be n choose k, choosing k objects from n without repetition, so without replacement. Okay. So that's a nice cheat sheet to have. And we have one more thing here, which is, you can think of this as the K1, K2, K3 up to K sub R sequence. Okay. And now here we're explicitly sort of allowing repetition. This is what we just described and what we just discussed with anagrams and so on and so forth. And so this will be the total number of objects that you're building your sequence for. Okay, so K1 plus K2 plus up to plus K sub R. So we'll list it under with repetition, or divided by, so factorial, divided by K1 factorial, K2 factorial, K sub R factorial. And, okay, so that's just a useful cheat sheet for counting. So try to identify, am I interested in a sequence? Does order matter? Or am I interested in a subset? Order doesn't matter. Okay, I'm just picking a collection of items. Am I allowed to repeat items? Am I not allowed to repeat items? And this is sort of, the case we studied today where I have a sequence. So it is a sequence, but it's not of length k. It's of length, the sum of these, and I'm required to pick a certain number of elements of each type. Okay, so let's erase, and we're going to come back and talk about overlapping sets and inclusion-exclusion, and then we'll talk about the pigeonhole principle. So I'm going to erase everything. Bam!